Okay, so this question says evaluate integral of e to the power x sine 4x dx. Now, how are you supposed to evaluate this? For you to evaluate this, you have to use what we call integration by part. You need to understand which part you're going to integrate and which part you're going to differentiate. So, definitely for us to know which part you're going to integrate and which part you're going to differentiate, all the logarithmic, inverse, and algebraic expressions you need to differentiate. Then all the trigonometric and other types of mathematical expressions you need to do what you need to integrate. So in this case, if you check clearly, you are going to understand that e to the power x has to be integrated, and then you go to sine 4x. This one can be differentiated. If you check both of the two, which is the natural exponential and trigonometric function, they are part of the integration. Now, for us to make it simple, it's better we integrate e to the power x and we differentiate sine 4x. After doing that, now we are going to plug in everything into the formula, and it will take into the same procedure which you are able to see there. So the same process which you are seeing there is the one that is going to be also taken whenever you reach on the third line there, where we have integral of e to the power x sine 4x dx equal to, so I said let u be equal to sine 4x, mean that I'm going to differentiate that as what? As 4 cos 4x. Then the integral, we are going to pick e to the power x and it will be integrated as e to the power x again. So whenever you plug into the formula, you will reach on the second part there where they're saying e to the power x sine 4x minus 4 integral of, sorry, before that we have integral of e for x, what we are from differentiating following the formula. And then on that same part, why did we replace where there is du with 4 cos 4x? It's because once we make du the subject of formula, automatically in the equation where there is du, you're going to have what? You're going to have 4 cos 4x dx. Then we don't integrate an expression with a number in between, hence we have to remove that 4 and put it outside. That's why it had to be negative 4 integral of e to the power x cos 4x dx. Now that part again, you are going to use the same formula which you are from using on top there, which is integral of u dv equal to u v minus integral of v du. You have to choose which part you're going to integrate and which one you're going to differentiate on that given point again. So you understand that once you choose the part, you're going to have e to the power x as the part that can be integrated, and then 4 cos 4 to be the part that can be differentiated. Then you plug in everything and you understand that it will be 4 open bracket u minus integral of v dv. So in this case, my u has to be what? 4 cos 4 x. If you differentiate that, you're going to get negative 4 sine 4x. Then whenever you integrate e to the power x, automatically it has to be what? It has to be the same expression. Remember, if for instance, if we had e to the power 2x, the integral of that has to be what? The integral of that has to be e to the power x over 2, something like that. And then you understand that the integral of e sine 4x dx is going to be what? Is going to be e to the power x sine 4x minus 4 open bracket cos 4x e to the power x minus integral of e to the power x. Inside the brackets, you put what you're from getting on top there once you make du the subject of formula, and you're going to reach on that same point. So remember, this 4 is outside the brackets and you have to multiply throughout by 4. So we're going to get negative 4 e to the power x cos 4x minus 16 integral of e to the power x sine 4x dx. So if you check the one which is having negative 16 integral of e to the power 4, the power x, I mean, sine 4x is just one and the same like what is on your left hand side, meaning that these two can be added and you're going to reach on the last point there where we're saying we have 17 integral of e to the power x sine 4x equal to e to the power x sine 4x minus 4e to the power x cos 4x plus c. Definitely the final answer is going to be on the next page. So this one qualifies to be the best answer of the integral of e to the power x sine 4x dx. We are going to get 1 over 17 e to the open bracket e to the power x sine 4x minus 4 e to the power x plus cos 4x plus c. That becomes the correct answer. Thank you.